Yes, good evening. First, a few words about me. My name is Arno Lepisk. I work as a software engineering consultant at a company called HiQ. I've been doing C++ for like too many years, 13 years professionally, and some more years before that. Today I'm going to talk about something I chose to call unexpected behavior. What do I mean by unexpected behavior? How many read this as undefined behavior? Everything I'm going to show is, to the best of my knowledge, well defined. One small exception that is implementation defined. Everything is legal, but it gives some kind of an unexpected results. I've chosen to classify these unexpected behaviors as in three different kinds. First, the odd ones. That's code that might look strange, and by looking strange, the surprise might be that it even compiles. Then we have the Murphy kind of unexpected behavior, and by that I mean something that a user might write, and by mistake it does something else than one would have thought. And last, the Machiavelli kind, where an evil programmer goes out of his way to trick or deceive the user. And please, don't try this at home. Or well, do, but don't try it in production code. Not anything I show here today should ever pass a code review. Let's start with an easy example. What will this print? What the code does is that it takes an int, and by number, it prints it. In first example, 15. What if we put this in? Any takers? Kind of odd. What happens here? In C++, as in C, every number beginning with a 0 is an octal number. So we're actually not dividing num with 10, but with 8. Anyone have done this? Yeah. And from my previous classification, I would classify this as a Murphy kind of unexpected behavior. Next, did you know that an URL is valid in C++ code? This will compile fine. But is it? If we add, then we get an error. What happens here? Any takers?
HTTPS.
Yeah, the suggestion was to use HTTPS. That works fine.
Label and a comment.
A label and a comment. So this would not pass a code review by several causes. GoTo, for example. Yeah, the label part and the comment part. I don't know how many of you are up to date with the newest or the next C++ standard to be, C++ 20. But if you are, you might have heard about the spaceship operator. And the spaceship operator is used to make three-way comparisons. Hopefully it makes code easier when you make your own type, the types that you need to check for equality, inequality, less, and so. But there's actually possible to make kinds of spaceships in earlier versions of C++. How? Yeah. One easy C++ 17 way is we'll define a template, and then that kind of looks like a spaceship, doesn't it? Like small cannons. But say you're not using this is with some modifications. You can use this in earlier C++ versions as well. And in C++ 98, we can write this. Or even that. That kind of looks like a TIE fighter from Star Wars, doesn't it? Like well, at least the special TIE fighter that Darth Vader used in the 6th film or 3rd, depending on which way you count. And with the same technique, we can make others if you use C++ 11. Does anyone know what happens here? Yeah?
Well, we're using tree graphs to escape like characters that some people may not type on their keyboard.
Almost. The comment was that we're actually using digraphs.
Ah, shoot, them, yeah, sorry.
C++ defines something called digraphs, and as the comment was, it's also a legacy from C, and old versions where char sets didn't have all characters for like the curly braces and the angle braces. So what we actually write, here's a table of the examples I just showed. Very closely related to the digraphs are the alternative operators. Also because some keyboards or character sets didn't have all, and it might be easier to write, and instead of the double ampersand and so on. But if we look, these aren't all alternative. There are some others for XOR and so on. But if we look at this table, some of these symbols can be used in for other purposes in C++. So these are the ones I could think of. There might be others. So instead of writing this, someone might write this. And then if you write a whole class, these are equaling. Please don't do this. And this works due to the translation between the different symbols, identifier-like operators, I think it's called. It happens so early in the compilation process, so you can use them in this way. But please don't. Okay, time for a small quiz. What will this code print? Any takers? I heard 0, I heard 1, I think. You're both correct and wrong, because this will print different stuff in C++ 17 and pre-C++ 17. And it all comes down to this. This is a trigraph. And what it actually is translated to, trigraphs are also used for old compilers that old systems that didn't have all keys. And they are evaluated even before comments are evaluated. So this will be translated to a backslash and a new line. And if you remember that correctly, it's a backslash followed by a new line is a line continuation. So the while is actually commented out. And the trigraphs are deprecated or removed from C++17 onwards. To be fair, at least with normal compilation settings, both GCC and Clang will warn about the trigraph removing a line. So this is actually what's evaluated in pre-C++17. More quizzes. We have an overloaded function foo, takes a char and an int. What's called in these cases? The first one is rather straightforward, a char. But if you add one to a char, what does that evaluate to? An int. Pretty straightforward. Then we have the case we add two chars. It's int as well. And now we're moving a bit into Murphy territory. Say we have this code with the same definition as before. And we refactor it like this. One would think that this would call the same code, but it doesn't. And this is due to a process called integral promotion, that all arithmetic operators on chars and on shorts is converting the chars to ints. And here's the caveat I talked about before. And this is dependent on a char actually fitting in an int. If it's not, it possibly on some platforms it's promoted to an unsigned instead. And this also is true for shorts. And this is actual usage I've seen of this, rewritten of course, in live code. This is equivalent to this. The plus sign promotes the character to an int. So you print out the ASCII value. Please don't do this. It's confusing it's very confusing. Next step. How many of you usually write using namespace std? No hands, good. One hand. Boo. It's rather okay, as long as you don't do it in header files, then I'm very disappointed. Okay, but let's refactor this. We remove the using namespace, and we get a compilation error. That's as expected. Vector is in std. So we add std and we press compile, and it compiles. Isn't that strange? Sort. It isn't in the global namespace. R begin, R end isn't in the global namespace. The slide title refers to one member of the C++ Standard Committee who shall be unnamed at this point, who referred to ADL as the devil. So what's happening is, as the V is of a type, standard vector, etc., it looks for the methods R begin and R end not only in the current namespace, but also in the namespace that V is defined. And this is called argument-dependent lookup. A bit confusing, right? And why I used r-begin and r-end instead of begin and end is because r-begin and r-end of vector are defined to return something in the standard STD namespace. Begin and end aren't technically required to do that, but all implementations I looked at do that. But how can this shoot us in the foot? Say we have this code. We have a struct in a namespace, and we make a function in another, in this case the global namespace, taking this as an argument. Works fine, writing that main method. But then we add a method in the namespace, and then now we got an ambiguity. How do you pronounce it? Ambiguity. I have to combine it, and you get an error. That's fine. Then you can correct it. If you have a slightly different example, we have our methods we call foo, and then we add a method in the namespace, and we recompile it, and it calls another method. Can be very unexpected behavior, right? So be very careful when doing. Yeah, a question, Harald?
Just a comment, this is actually relevant if you implement your own swap implementation.
Excuse me.
If you implement your own swap,
Yeah.
then actually you need to make use of this and write using a namespace.
Yeah, the comment was that this can shoot you in the foot when doing a swap operation and others. That
User-defined swap.
yeah, user-defined swap. Yeah.
You need to using namespace STD because you might have your own swap implementation that should
Yeah.
go to the wrong implementation.
And yeah, so you need to be very careful when doing methods that take arguments that are in a different namespace. Next example, short-circuiting. I know that short-circuiting is much more common in other languages than in C++, but do you understand what I mean when I say short-circuiting? Is that in this case, if PTR is null, PTR foo isn't called, as the expression cannot be true if one of them is false. And another example is you can do this with a OR function. If in cache is true, then the other method isn't called. But this can be short-circuited. Say that we have made our own smart pointer for some reason. This won't compile because it doesn't know how to do the and then. But then we add, and then you might be, I'm smart. I'm going to add a little operator overload for this. And it works fine until someone puts in a null pointer there. Because in order to evaluate this, it has to do both sides and put it into the AND operator. You understand that? That's clear. So how do you avoid this situation? Yeah, it's better to add an operator, a casting operator to bool to your type. Because the short-circuiting properties of the logical operators is only defined for built-in types. And then it works. Punctuation problems. How many have accidentally put in an extra pair of parentheses? Very easy if you use an ID. What will be called here? A bit strange. Or? And the comma operator is tricky. I think we had a talk about the comma operator a couple of years ago, right? Harald waves. And if you, for some reason, depend on the comma operator, this will give different results. Why is that? Yeah, because the comma operator has the lowest precedence, or amongst the lowest precedence of all operators in C++. So this is actually evaluated like that. Assignment has a very high, oh, no, not very high, but it's higher than comma. And now we're entering Machiavelli territory. Because the comma operator is defined by default for most things, but you can override it. So if you, for some reason, depend on the comma operator, an evil library constructor might write something like this, and you get very different. They could even make something that returns something entirely different, like an int instead. Yeah.
Could that be templated for everything?
The question was, can it be templated for everything?
Unfortunately, yes.
Yeah. Yeah, I got an answer from the audience. It was unfortunately yes. But who uses the comma operator anyways, right? If you ever done a for loop, looping over several indexes, you're actually using the comma operator there in the last part. It's fine as long as your comma operator does something even remotely sane. This is a way to get around if someone makes a comma operator that isn't sane. I know that at least one STL implementation does this because users of their STL didn't do this, so it broke down all their algorithms. So if you cast one to void, because you can't overload on void, you're home free. Let's go back to the first comma example I had. I actually saw this on Twitter yesterday. What happens if you write that?
Nothing.
Nothing happens, yeah. And I can actually see this happening by mistake. This isn't Machiavelli, this is plain Murphy. Okay, how do you take an address of an object? This is right. But remember, we're dealing with Machiavelli. The address of operator, what we might call it, the AND sign, can be overloaded for any type. It can be overloaded out of class. So you're on your own. Luckily, there's a way around it, and it's std address of, and it does some if you ever looked at the code of the address of, it does some really nasty casting and actually always is guaranteed to return the actual address of. Personally, I don't even understand why you would ever want to overload the operator end unless you're Boost Spirit, because they overload everything. But yeah, there we are.
One question, should you use address of instead?
The question was, should we use address of instead? Yes, if you need to take the address of something in code someone else uses, to be absolutely safe, you should do this. In most cases, no, but be aware that strange things could happen. Yeah, because you never know what the address of. It all bubbles down to, do you trust your library writers or not? So, in conclusion, C++ is a complex language. Please don't make it worse by tricking and surprising your users. Don't overload logical operators unless you have a very, very good reason to. You probably don't. It's better to cast to bool and then do the actual operations on that. And and this goes for all operator overloads, please be logical. Don't make your addition operation do a subtraction. The only thing that's by convention is okay, it's very illogical that we use the bit shift operator to output on streams, but that's so common, so everyone's used to it, so that's fine. Thank you. Questions?
Show the very first example again, because I must have missed something.
Very first example. There must be a better way to do this.
Yeah, the double zero, I guess.
Yep.
So the double zero is just leading.
Yeah, the double zero is just there to trick you. Because that's all, one is one in octal or in decimal. Yeah?
I have a question. This alternative operator names and or are these standard? Because this bit me once, because Visual C++ doesn't seem to define or and I once ported something to Mac, and that bit me because there these were defining some header file that it ultimately pulled in from some framework, and it suddenly didn't work.
Yeah, the question was about the alternate operators, if they are standard. Yes, they are standard, but not in C. Oh, they are standard in C, but in order to use them in C, you need to include something. They're defined as macros. In C++, they are, to the best of my knowledge, built into the language.
I think for Visual Studio you need to include the extra header ISO something to have that.
Okay. The comment.
I think in Visual Studio you need to include the something ISO something operator with a number that you have the end keyword and the or keywords.
The comment was that the Visual Studio actually requires you to use some kind of header include to, yeah. Even in newer standards, in newer versions.
The last time I tried.
Okay. To the best of my knowledge, it's standard. I might be wrong. Yeah.
Yeah, the address of operator you told,
Yep.
is that zero cost or does it do a lot of checks and add additional?
The question was if the address of, you mean in the standard STD : address of, if it's zero. Yes, it should be. At least if you, it does some costs, but as far as I understand it, that always is done at compile time. If you compile without any optimizations, it might be something, but I think it's that those costs that are done at compile time. Okay. I don't see any more hands. Okay, thank you.